Hi, and welcome to Cybrary.it. My name is Anthony, and in this segment we'll be talking about different display devices and more information on the exact specifications and technology used behind them. I'm the local subject matter expert here for A+, so let's go ahead and get started. One of our technologies that we need to start talking about for our display devices is CRT monitors. Now, CRT stands for Cathode Ray Tube, and this is a little bit of an older technology that we're starting to phase out more and more for many different reasons. But they're still quite often in use, and they're still very popular in some places, and we need to know a little bit about them, and we need to know how this technology works so that we have a full understanding of the technology behind display devices. Our CRT stands for Cathode Ray Terminals, and essentially what our CRT monitor does is it shoots electron beams onto a phosphorescent screen. So it takes our CRT beams that are in the back of our monitor. So when we're looking at our monitor, we can envision the front of our monitor here. And our monitor is going to go back into a space with our cathode rays. Now, inside of our monitor, most of this space back here, and this is going to be our plastic monitor, is going to be an empty vacuum tube for most of this space. That's why you'll see our cathode ray terminal computer screens, our CRT monitors, are going to be the big bulky television, or the big bulky monitor screens. They're not going to be like our thinner screens that you'll see now, like our LCD screens. They're going to be big. They're going to be very heavy in one side, and they're going to be hard to manage, which is one of the reasons we're moving away from them. But these electron beams are here in the back, and they shoot red, green, and blue electron beams. Commonly, you'll hear we have video screens that display video in RGB, or red, blue, green. And so that's what we have. We have the red, blue, and green. These red, blue, and green electron beams pass through an area with coils that are actually known as deflector coils. These deflector coils here move and angle these beams against our screen. And these beams sweep across our screens, shooting the electron beams at them. And that's how we get our picture. Again, remember, this is from our side view. This is the front of our monitor, and this is near the back. So these deflector coils angle this beam where it wants it to point. Now, this happens several times a second when it passes over. That's called the refresh rate that we'll get into later. But this refresh rate is essentially how many times per second the beams refresh over the monitor. Now, before the beams actually hit the front, before they hit our phosphorescent screen, which react to these electron beams, they actually pass through something called a shadow mask. And a shadow mask helps to separate these beams and hit them exactly on the pixel where they need to be. So we have like our shadow screen here. Our shadow screen uses a couple different types of technology. One of the technologies we use is called a pixel triad, which is a grouping of 3 colored dots that the electron beams hit in order to increase the red, blue, or green content within that pixel triad, receiving either, again, from the red electron beam, the blue electron beam, or the green electron beam. In addition to this pixel triad, we also have something called an aperture grill, which is thin vertical metal strips, and this is a close-up view of our shadow mask here. Thin vertical strips in our metal, which essentially prevent stray beams from causing issues on our screen. The electron beams aren't perfect. They can, depending on what we have sitting on around our screen, if there's additional magnets or if this shadow mask becomes slightly magnetized, the beams can get a little bit off kilter where they're going. And in order to prevent them from hitting on our screen and creating a distorted image, there's this aperture grill, which are these thin vertical metal strips, which it has to pass through, and it deflects some of these off-center beams. You may also hear a slotted mask, and slotted mask just combines this pixel triad with the aperture grill in order to create sort of a double sense of security in its shadow mask. So again, the shadow mask can have pixel triad, an aperture grill, and it can also have, when you hear slotted mask, you're thinking of both of these technologies added together. Now, we talked a little bit about how magnetism on our shadow mask or on our slotted mask here can cause issues when we're trying to display a picture with our CRT monitor. These electro beams are actually moved by magnetism. The individual particles, if we have a case where this mass is getting magnetized, can actually become deflected and start going in directions where they shouldn't. They can become sticking to it when we really want them to pass through and get to where they're going and hit our screen and illuminate it. So CRT monitors have something that's called a degaussing button. Now, a degaussing button may just be an actual button on the CRT monitor, or it may be a setting that you have to go through the menu and select to degauss. A degaussing actually demagnetizes our display. When we haven't degaussed in a while, we'll see that when we press the degaussing button, the screen will go haywire for a second. Everything will become distorted. And then after a few seconds, it'll return to normal, or possibly even a little bit better than it was before, because what that has done is it's demagnetized that entire display to get rid of some of that residual magnetism, which may be causing slight distortion in our image. The degaussing isn't something that we want to do all the time. Demagnetizing our display can actually reduce the life of our CRT monitor, and it can cause damage to the monitor over time. So while it is something good to do when we're noticing issues or we're noticing possible slight distortion in our screen, we don't want to just make it a habit to degauss our monitors just for the fun of it. So we do want to keep it in mind that it is an option and it is something we can do, but we'll keep it to a minimum and we'll do it when it needs it. We want to keep in mind that when it comes to CRT monitor disassembly, there is high voltage in CRT monitors. There's a lot more voltage in a CRT used to run a CRT monitor than, say, just a standard laptop monitor or an LED or LCD screen, just because of the nature of having all the magnetic components being powered, the electron beams and the deflector coils. We need to be conscious of that high voltage that can pose a danger to us. So we don't want to, unless we're experienced in it, unless it's something that we've been trained in, we don't want to just use this little bit of information that we know about CRT monitors to begin trying to disassemble one if it's not working.